Hey everybody, ABC 10 meteorologist Brendan Minchef here with another drought update. It's also a new water year, so we're going to talk a lot about the water year that was, and we're going to look ahead to the new water year as our wet season is beginning to ramp up as we work through October. It's kind of the on-ramp to our wet season, if you will. But before we get there, let's talk about September real fast, because we just finished the month of September, which is also the last month of our water year. And we started off pretty warm in September, above average temperatures in the 90s. The warmest day was 96 degrees. But then by the last half of the month, we were in the 80s, low 80s for the most part. And we even ended the month of September with a high temperature of 70 degrees. So here is the calendar for the month of September. At a few days that were near average in the green there. By the early part of the second week, third week of the month, we were in those 90s, though, up to 96 degrees. This week felt very, very warm in those 90s. But then finally we had that turnaround and it really started to feel like fall in those 80s in Sacramento. And again, we had a temperature of 70 degrees to close out the month of September. I kind of talk about this because there's a couple things that are significant about the month that we just had. There were no triple-digit days in September 2023. That was the first time that's happened in the month of September since 2018. On average, we have at least 3 days with a high temperature of 100 degrees or warmer. The other thing, it was a cool month. You saw we had 20 below average days this past month, and that was the coolest since 2007 by high temperature. So the average high temperature this past September was 86.1 degrees. 2007 was 83.4 degrees. So it has been a while since we've been as cool as we just were in September. So now that it's October, now we really expect the seasons to change, of course, with the pumpkins and the leaves changing colors. The average high at the start of the month is 85 degrees. By the end of the month in Sacramento, the average high temperature is 72 degrees. But we also see a significant change in the overnight low temperatures. The average low temperature at the start of the month is 56 degrees, but by the end of the month, it is 49 degrees. So those early mornings are going to get a lot cooler as we go through the next 31 days. But I got to tell you, here in Sacramento, over the next week or so, we're going to go the opposite direction. We're going to be warming up. We're going to go back into those 90s, which is something we haven't seen in Northern California since the early to middle part of September. It's been a few weeks. Low pressure going to move to the east. That's the storm that we just had that brought us some rain. Moving off to the east, high pressure will be taking its place. So as we go into October, which of course is fall to a lot of people, you think fall and probably the next thing that you think is October. As we go into October, we're actually going to be warming up. And I got to tell you, looking out about 15 days or so for Northern California, I'm not seeing a lot of cool down relief. I'm just looking at some 80s and 90s going forward and not a whole lot of 70s until we start looking towards the end of the month of October. That's kind of the forecast portion / where we were, but the real meat of this story, we're going to be talking about the water year, of course, and we're going to start with the precipitation tracker. This is for the year that just was. So even though it says this month, this season, this ended yesterday on September 30th. So we had 0.07 inches of rain downtown Sacramento in September 2023. That's 0.07 of an inch. That brings that water year total to 26 inches and a quarter, 26 and a quarter inches. The average for the last 30 years, 1991 to 2020, is 19.2 inches of rainfall. So we were 7+ inches to the good on the water year, even though September was a little bit drier than usual. It doesn't matter. We had a lot to spare. We had a lot in the bank. 7 inches to the good in downtown Sacramento. Now we look back at some recent water years. That 26 and a quarter is better than where we were in 21-22, in 2021, and 19-20. In fact, it was even a little bit more than what we saw the previous time we were above average in 2018-19. So the last time we had at least 26 and a quarter inches was the water year 2016-17. So that would have been October 2016 to September 2017 when we had almost 34 inches of rain. You can see that 30-year moving average is about 19 inches. So again, we were well to the good with the water year that we just had. And it wasn't just us in Sacramento. It was the entire state of California, from the southern border to the northern border, from the Pacific coast to the Sierra. Everybody saw a good water year. Here are those numbers for some cities across the state. Eureka, almost 43 inches of rain. Redding with a nice round 41 inches. South Lake Tahoe, 38.5 inches. San Francisco, about 31.5 inches. Stockton, about 23.25. Fresno, just about 18 inches. Bakersfield, about 11.25 inches. Santa Barbara, almost 29 inches of rain. Los Angeles, about 26.5 inches of rain. Palm Springs, 7 inches of rain. And then San Diego, 15, a little more than 15.5 inches of rain there. Now, that is the total amount of rain. So if you stuck a ruler, if it was like snow and you could stick a ruler in the amount of rain that we saw since October 1st, 2022, those are the numbers. But here's the real numbers that we really want to see. Everybody's in blue, right? This is telling us the departure from normal. You don't see any negative numbers on there, which is great news. That means we were all above average this water year. Palm Springs was about 2.5 inches above average. Los Angeles was over 14 inches to the good. San Diego, about 6 inches to the good on the water year. San Francisco, about a foot to the good. South Lake Tahoe, 18 inches above normal on the water year. And of course, as we talked about, Sacramento, about 7 inches above normal. Stockton, almost 10 inches above normal. For Northern California, for Central California, a lot of that was due to the winter that we had. We had well above average rainfall by the time we even got to about March, April, May. And then for Southern California, while they were also doing well and above average, these numbers really went up when Tropical Storm Hilary moved through the southern part of the state and really just added on to the great water year that they had. And of course, Los Angeles, 14 inches above the average for the water year. We can chalk up quite a bit of that to what was Tropical Storm Hilary. As we look at the reservoirs right now, 73% capacity Shasta and Oroville, 68% capacity at Folsom. Obviously, these filled up because of the wet winter that we had. They were all very low. The drought was horrible as we started last water year. What a difference a year makes. Here's what the map looks like now. Just a little bit of that abnormally dry category down in this very southern part of the state along the Colorado River, and then along the Klamath River in the far northern part of the state as well. 5.93% of the state is abnormally dry. Only 0.07% of the state, less than 1% of the state, is in technical drought right now. Most of the state is not in any drought whatsoever. There is really no drought to be had in California right now, which is great news. Again, such a huge improvement from where we were a year ago. This is what the drought map looked like a year ago. The drought score was at 351 out of 500. You want that number as low as possible. We were well into the 300s at that point. It did get a little bit worse as we started the water year, but then it got better, and it just kept getting better. Today, that number's down to 6. And again, we just looked at the map. Here's what it looks like as we start the water year of 2023 to 2024. Terrific improvement over just 1 year. And as we start to go into this rainy season, as I mentioned, the average rainfall downtown Sacramento for October is almost an inch of rain. As we go into the rainy season and we start expecting more of these storms, some atmospheric rivers to start making their way through during the wintertime, it's also a building El Nino as well, which typically means we will see at least an average year's worth of rainfall during the wintertime, at least an average wet year in California, especially as it relates to southern into central California. It's a little bit of a toss-up in northern California, but the point is we've got the ocean and the atmosphere working in our favor. Last year we had La Nina. We had a lot to overcome. We didn't expect it to be as wet as it was. It was kind of a nice surprise. We've got a lot of scientists working to figure out why exactly it was wetter than expected, why the models didn't pick up on it. But this year we've got things working in our favor. We've got a very classic El Nino signature just off the coast of South America as it extends out across the equatorial Pacific. And we also have some warm water off the coast of California right now as well. So all of these things are pointing to an above average water year. But let's actually take a look at the numbers, right? Let's not just assume it'll be an above average year. Let's actually break down some of these climate models that we look at. This is the North American Multi-Model Ensemble. It's a climate model, not a weather model. So when we talk about Futurecast or we talk about the weather pattern that we showed a little earlier in the video, that's a weather model. It goes out depending on the model. Some of them, the high resolution ones, only go out a few days, about 48 hours or so. But these climate models go out months. Now, they're not as the resolution's not as good, right? Like we can't say, oh, it's going to rain on December 15th and January 1st, right? But we can say generally, this is for the month of November, generally what the weather pattern is looking like, what the atmospheric setup is looking at. And it also takes into account climatology, right? So are we in El Nino? Are we in La Nina? It just takes all those things into consideration and puts it on a map for us and says this is what it looks like we could see. So this is showing us precipitation anomaly, above or below average. The deeper the red, the more below average, the brighter the blue, the more above average. And so what we see across much of the West Coast is actually below average precip for November. Now, this actually includes really all the way from Central California up in towards British Columbia and all the way in towards parts of the Gulf of Alaska as well. That's for November. Let's look at December. Here's December's map. And you can see kind of a similar story. A lot of red still on the West Coast, whereas the East Coast seeing a lot more of that green, above average rainfall. Kind of a different story once we get to January. Here's what January looks like. And now we start to see some of that green. And you can also notice that green that extends out into the Pacific as well. This would be kind of indicative of an atmospheric river pattern, or maybe multiple atmospheric river patterns for January. Not unexpected, right? Again, we can't say January 20th, we're definitely going to see an atmospheric river. That's not what we're saying here. What we're saying is the overall pattern, the climatology, everything that we're looking at is hinting at chances of rain being better than average for January. And again, it would not be unexpected. I mean, when we get, January is our rainiest month. When we get these atmospheric rivers, we expect to get them in months like December, January, and February. So seeing that signature like that is not unexpected. You would actually kind of hope that you would see that if you're looking at forecasting rain, if you're looking at expecting and hoping for a wetter than average January. Here's the month of February now. A lot more green across the Pacific and in towards the West Coast, including for the state of California as a whole. And you see a lot of that darker green as well for far northern California, which would be some good news, right? We would get some more rainfall in there, and that's what we would want to see. We can kind of aggregate these as well over a 3-month span. So these are maps for December, January, February, all put together, right? The three-month span as a whole. For the NMME, this is what it looks like. And you can see December through February, a near to an above average period expected from that national blend. We can also look at the European model. They do the same thing, running it with the European model. They do it for 1-month anomalies. They do it for 3-month anomalies. This is the 3-month anomaly, December, January, February. And this is showing even a little more green, but still near to above average for much of Northern California. You see that darker green out over the Pacific, and then you also see it kind of along the Atlantic into Gulf of Mexico near Florida as well. That's where that dark green is. So that's why it's not above average, but we'll say near to above average. So there's, looking out, there's hope. But I also want to put a little asterisk on this because we looked at these same charts this time last year when we started talking about entering that rainy season. And we said, well, it looks like it'll be drier than average. Looks like it'll be drier than average. There might be some hope as we get in towards January, February. But of course, it turned out to be quite a wet winter as we just looked at through this video with all those numbers. We all remember the scenes of the rain and the snow and how often it rained and on the wind as well. We had dozens of atmospheric rivers make their way through the state of California last year. So these models give us a hint, but they can't tell us the full story right now. The math just isn't that good. The models aren't that good. And especially here in California, we don't live in a flat state where it's easy for the numbers to crunch, where it's easy for the supercomputers to really detail some things. Now, are these models better for different parts of the United States? Sure, especially where there's flatter areas because mountains really do a number on the weather pattern, right? I mean, think about it. How often does Sierra see snow when we see rain? But if that area was flat, we would all see rain, right? We wouldn't all see snow because the elevation helps to make things colder, helps to induce that snow to fall instead of it falling as rain. So elevation is really important. And in California, we've got a lot of elevation changes. We've got a lot of microclimates, and all those things kind of throw a wrench, if you will, into some of these models, both weather models and climate models. So it's just something you got to take into account. Last year, we thought it would be drier than average because we had that La Nina still. The numbers, the data, the models were all telling us that it looks like it might be drier than average. Turned out not to be the case. So we could look at these, and even though November, December looked like might be drier than average, might not be true, right? It's just giving us an overall picture, an overall idea of things to kind of look for as we get closer. So as we start getting closer to November, we'll start looking at those weather patterns. Does it look like the pattern is setting up to be drier than average? As we get to December, January, does it look like we're trending a different direction? Does it look like we're trending wetter than average? Not meant to be live or die by these climate models. It is simply meant to help us kind of forecast out, especially for water managers, to kind of forecast out, to kind of look out and see, what do we have coming? Is it a lot of rain? Is it an average season? We actually spoke with someone that does a lot with these climate models and is really good with these numbers and data. And he has a lot to tell us, including, like I said, sometimes they're just not always right.
The forecast models that we use to make seasonal predictions, they are really showing some pretty meager chances in the probability of above average precipitation. It's a little bit of a head scratcher because this isn't exactly what we would expect out of an El Nino event of this magnitude.
Andy Hoyle, a research meteorologist with the NOAA Physical Sciences Lab in Boulder, Colorado, works with climate and weather forecasting models and prediction, especially on a seasonal scale.
Yeah, seasonal forecasting techniques generally involve long-lived and slow-varying processes like the El Nino Southern Oscillation and how it tends to shape a given winter's precipitation or a given wet season. Then within a given winter, you have variability in the climate system that operates on weeks and a couple weeks, maybe a month time scale. And those can take the shape of just atmospheric patterns, like the PNA pattern, the Pacific North American pattern, or they can be related to other variabilities within the system, the Earth system, like the Mann-Julian Oscillation, which last winter had a really profound effect on California. So you go back to last winter was forecast to be below average for precipitation because of La Nina. Then the MJO decided to be really active over the course of a couple of weeks at a couple different discrete points in the wet season, and had copious precipitation because of it. And what can otherwise change a forecast, which we were pretty confident in a below average precipitation forecast, and ruin that forecast so that precipitation was actually above average.
While many factors contribute to wintertime precipitation in California, or the lack thereof, El Nino is generally the strongest and most reliable predictor.
El Nino is a coupled ocean atmosphere phenomena in the tropical Pacific Ocean that has wide-ranging effects across the globe. And those wide-ranging effects include changes in precipitation and temperature over areas like California, the United States, and even as far away as places in like Western Asia. Strong El Nino events have a pretty big effect historically on precipitation in California and the general southwestern United States. Moderate events do as well, but don't have as much of an effect. We have warm sea surface temperature anomalies in the central and eastern tropical Pacific Ocean, and the tropical atmosphere is slow to get on board and respond to that. But the atmosphere and the ocean are now working in tandem right now to really produce the signature of a strong El Nino event.
And strong El Nino events are rare, but generally they mean a near-average precipitation year with the potential for a very wet year.
When you look at the historical record that we have that really goes back into the 1950s as it relates to El Nino events, we usually only have about 6 to 7 strong El Nino events depending upon how you categorize them. And of the strongest El Nino events like 82, 83, 97, 98, 15, 16, we only have 3. So that's why we need to supplement our observations with climate model simulations in order to increase the sample size to see what the true robustness really is. I don't think we can entirely discard the information that forecast models are providing because sometimes they do have insights that we don't have. I'm not a supercomputer. Then again, we have a historical basis for what we understand the effect of strong El Nino events to produce over California and the greater Southwest. And that really needs to be taken into account when we're making a prediction of an upcoming strong El Nino winter.
But predicting the future is hard, especially when you have a small sample size of strong El Nino years. So although the general consensus is for a near average to above average winter, it's important to realize there's also a chance for a drier year, even though the odds aren't as good.
I think we have an elevated chance of above average precipitation across the state, certainly more of an elevated chance the further south you go because of historical relationships we've seen with El Nino and California precipitation. But As we've seen in the past, when we only see a 40 or 50% odds of above average precipitation, we still have a 50% chance of average or below average precipitation.